So today we're going to be moving into section 4B. In section 4B, what they wind up talking about is the power of compounding. Okay, that's the title of the section. And what 4B is really going to be looking at is an answer to, Chuck keeps saying, I got to take money out and put it toward retirement. Why am I putting my money into retirement? I want to have fun with it now. My brother made the comment to me once, no, we're not bothering saving much money. How do I know I'm even going to live long enough to retire? And my comment was, if you live long enough to retire, that could be a very painful time. Okay, retiring on nothing is hard. Okay? So, what 4B is going to look at is this money that you're being encouraged to take and invest in retirement is going to grow. Well, how does it grow? It grows through a process of interest being placed on it. And that's where the growth comes from, is from the interest. There are several different ways to apply or compound interest. One of the ways to compound interest is what is called simple interest. Okay? And they start this section off with kind of a funny story. It's a true story, and it dates back a few years. In fact, it goes back to July 18 of 1461. And the story goes that the King of England at that time was at one of the universities in England, and for whatever reason, he borrowed what would have been the equivalent of, in that point in time, $384. I don't know if you wanted to take the Queen out for lunch or something, or whatever the deal was, but he needed some money. And he borrowed it from the university. And as politicians are given to doing, they'll take money, but they're reticent to give it back. Okay? Glad to take it. Of that, he returned $160, adjusted to today's standards. Okay? Which meant that there was an outstanding debt of how much money? Looks like about $224 was still owed. Okay? So if he returned 160, the royal family still owed about $224. Well, you know how it is. One thing leads to another, and you get busy and you just forget. And the royal family never did pay the university back. Well, a few years later, 1996, the university, more jokingly than anything, pointed out, you know, King da-da-da borrowed some money from us, and he still owes us $224. And it was more just as a funny thing, you know, they didn't really expect the money back. But one of the accountants figured out how much was due. Well, there are a couple of ways to compute interest on this after this period of time. Well, first off, how long is this that this loan's been out now? By 1996, which, geez, that's over 20 years ago, isn't it? About 535 years? Okay, so yeah, this is a debt that's been outstanding for a couple of years. So at this point, it's been outstanding for 535 years. Now, there are a couple ways the university could go about computing the interest. And they said, we'll keep it fairly straightforward over this last 500 years, about a 4% interest rate. Would have been reasonable, nothing outlandish. Okay. And they said there are a couple ways that we could do the interest on this. One way to compute the interest is with what is called simple interest. Simple interest, as the name implies, is pretty easy to figure out. Banks and investments, retirement accounts, things of this nature do not work under a premise of simple interest. You'll see why in a little bit. There are some investment areas where they do work on simple interest. For example, bonds. Anybody know what a bond is? Yeah, it's a secret agent from England. Bond. James Bond. What is a bond? Please? Okay, yeah, one way is, you pay bond. If somebody gets in trouble and they want to be walking around free between then and when they are scheduled to appear before court, okay, you can pay money. What's the point of that money in that case? To get out. And why do you have to pay money to get out? Well, the idea is if you pay enough money, or whomever pays enough money, they're going to want that back, aren't they? Yeah. And if you skip town and you skip bail, who gets the money? The jail. Yeah. And they use it to track you down. Oh, the bail. Yeah. Okay. So the idea of the money there is to kind of say, look, I'm definitely not going to skip town. And your brother-in-law who posted says, you're right, you're not going to skip town. Okay? And it's just insurance that you're going to be there. Okay, and you get back a chunk of it that you're charged by the whatever system, a portion, but at least you get a good chunk of it back. Another way that bonds work is, let's say the city of Cincinnati wants to build a new stadium. Okay? And they need money for it because they just don't seem to have it. One way that they can raise money is by voting on a tax and putting a new tax in. Okay? Do you see what they're doing now? There was a tax that was voted in to restore Union Terminal. Union Terminal has been restored, and what was voted on was the money would be used to restore Union Terminal, and then the tax would be dropped. Did you see what the city council did? Union Terminal has been restored. They voted to keep the tax because they want the money for other stuff now. So what the people voted on was, yes, taxes for this long to pay for this. And city council said, yeah, we're going to keep that tax going and we're going to use it for other stuff. Okay? So if you live in Cincinnati, you got to keep an eye on it. But they sell a bond to build a new stadium. With bonds, the idea is you give them a chunk of money. That money is collected up. It is used to build whatever infrastructure or stadium or whatever they need to build. And the deal is the city will pay back the money that you give them in 30, 50 years with a given rate of interest. And they won't charge you any tax on it. The fact that they don't charge you tax saves you some money. Okay. However, they're only paying you simple interest. Simple interest does not add up anywhere near as fast. Okay. But sometimes people want to help a particular situation and they just put the money in to help it out. The point of this example with this king is to show the difference between simple and compound interest. And also to point out how you compute each of them. With simple interest, what you do is you just take the amount owed, in this case $224, and you multiply it times the interest rate. Now be careful, it's 4%, so do we multiply by 4? She's on it. You're absolutely right, you don't multiply by 4. You have to change it from a percentage back to a decimal. Well, as a decimal, you're going to slide the decimal 2 places, and you get 0.04. Does that make sense to everybody? Everybody's good? And when you multiply this out on your calculator, you get $8.96 interest each year. Okay, so what they look at is what's the initial amount, how much is the interest on that, and they pay you back $8.96 in interest each year. Okay? Well, if we figure this out over 535 years, what the royal family would owe is they would owe the $224 on the loan, wouldn't they? So they would owe the principal. The principal is the amount of money that's initially involved. Does that make sense? Plus, the university should get a check. Okay? Remember, they're the ones who are going to be paid the interest, right? The royal family owes them interest because the royal family has the money. Okay? The royal family should be sending them a check for $8.96 each year for how many years? 535. Yeah, for the 535 years. So over that time frame, yeah, it's $4,000 or $5,000 in interest that they should have been sending to the university, but they didn't. So what you do is you say, okay, you owe us a total of $224 plus you owe us $8.96 times 535 payments of $8.96. Does that make sense how this works?
Yeah. So you have paid the amount that you originally borrowed plus interest.
That's right. You got to pay back what you originally borrowed plus the interest. Well, this works out, if I poke the buttons right, $47.93.60. And you got to pay back the $224 that was originally owed. So that means the royal family would owe the university $5,017.60. That's pretty doable, isn't it? Okay? Now, as far as the royal family is concerned, they're getting off cheap. Paying off a 500-year debt for $5,000. Okay? That's all done. On the flip side, if you are investing money for retirement, does this look like this is growing anywhere fast enough for you to be able to have anything to retire on? No, because you got to wait how long? Over 500 years? That's right. In 500 years, you're really not going to care about that money anymore. Okay? Everybody had a chance to sign? Everybody's good? Well, there are other ways to compound interest. Simple interest works like this. You just take the original amount, the principal, plus the interest that's due for 1 year times how many years do you have to pay that. That's simple interest. Compound interest works a little differently.
Is that how they do our loan, our student loan?
The way they do your student loans is a form of compound interest.
Okay.
So it's coming up. There are several ways to do compound interest. We're first going to take a look at what is called continuous compounding. And you've got to know the difference, because when you are signing paperwork for student loans, for car loans, for a mortgage, don't you want to know how they're charging out that interest? Yeah. There are a number of ways that it can be done. First off, you're not likely to ever see simple interest. It doesn't do anything, does it? So you're going to be looking at compound interest. Continuously compounded means every second the interest is added on. And what you wind up doing is, let's turn this around and let's say it's an investment. Okay? So you put money into some form of an investment, you give them $1,000. You've been saving up, you got $1,000. Christmas money, birthday money, graduation money, and you put $1,000 in. At the end of a month, to keep it simple, let's say that the company pays you another $20 in interest. okay, which is not bad. That's pretty decent interest. $1,000. At the end of the month, they put in 20 bucks. At the second month, they pay you the interest on the $1,000, but you know that 20 bucks they gave you last month? This month they're going to pay you interest on that. Oh, so I'm getting interest on my interest? Interesting. Okay, so the second month they're going to pay you 20 bucks plus the interest on the $20 they gave you last month. The next month they're going to pay you interest of 20 bucks plus now how much interest is in there? It's a little over 40 bucks, isn't it? And they're going to pay you interest on that. So each time they pay interest, the amount that it's paid goes up, doesn't it? Because not only is it the original amount, but it's the interest on the extra money that you've also got. Not money that you've had to add personally, but money that's been added in the form of interest. Okay? If it's continuous compounding, basically every second they're putting interest in on what you have, plus the extra interest that you got all the way up to the last second. The formula for computing continuous compounding, and you need to know this formula as well as how to use it. It'll be on Friday's quiz. Is this. I always remember it as PERT. P times e to the RT. Okay, so what do these various numbers mean? P sub 0 is the initial investment or the initial amount. So if this is a loan, like a student loan, P sub 0 is the amount of money the bank or whomever gives you up front. Okay? If it is your retirement account, P sub 0 is the amount of money that you invest in that account. R is the interest rate. In the case of this problem with the king, it was 4%. T is the number of years that money is going to sit there. Everybody good so far? Okay. If we take this information that we have, we can identify these different numbers for the situation with the king. What's the initial amount of the loan? It's the $224, isn't it? What's the interest rate? 4%. How many years? 535 years. Yeah. Okay. If we take those values and substitute them into the equation, we're going to have P of T. What's T equal to? Years, 535. On the left-hand side, this is a label. In math, that's a label. That's a title. It says this is the amount of principal, the amount of money that's going to be there in 535 years. That's what that says. In math, they use all kinds of abbreviations, don't they? Real short ways of saying long sentences. Okay? What's P sub 0? 224. E is a number. It's a calculator key, hopefully on your calculator. We'll talk more about that in a moment. R is the interest rate. Now be careful, you never put it in as a percentage, you put it in as a decimal. And that's going to go in as, let's see, we slide the decimal over 2 places, it's going to be 04 times, everybody's good with the 04? Then T is going to be the 535 years. Everybody good so far? All right, so that's what we're going to use. I'll see if I can whip up this calculator here. See, there we go. How's that? Look at there, calculator. And the cool thing is, it'll get recorded. All right, So how am I going to enter that in to the calculator? Well, the first thing I'm going to do is I'm going to do this portion right there. I'm going to work with that part of the formula. Slide this over a little bit so that the calculator doesn't just disappear on us. And on your calculator, see where it says natural log? If you have a TI-83 or 84, if you have some other flavor of calculator, you'll need to look around. There should be a button that says E and then X. On the TI-84s, it's written in blue. Well, to get to a blue key, you come up to the button marked second. It's a blue button. And then press, and you'll get E to the X. On some calculators, this will be displayed as E and then a caret and a parentheses. Okay, on this calculator that's showing here, it shifts up to the exponent. And then what you type in is the 0.04 times the 535. And close the parentheses. Whoops, I guess I don't need to do that on this one. Okay. Do you have that in on your calculator? Make sure you've got that in and working on your calculator. Then you press enter. Whoa, look at this giant number comes back with. It's 1967, 441, 884. That's kind of like a big number, isn't it? So this value for the E is going to be 19674418884, but that's not the amount that you wind up owing if you're the king. Bless you. Because that still has to be multiplied by 224, doesn't it? Well, instead of retyping that number, all I have to do is press times, and see where it says ANS? That means it's going to pick up whatever the answer was, and I'm going to multiply it now times 224. And press enter. Here's how much the king owes. If you work things out with compound interest, you wind up with 4.407, and I'm not copying down the rest of the numbers just because of time. You wind up with that much money. Huh. Interesting. That means we're going to slide the decimal how many places? Going to slide it 11 places, aren't we? Well, to slide it 11 places, I'm going to put down my 4,407, and I'm going to start moving that decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to put a 0 in for each of those. That's also supposed to be a 0. And I'm going to get rid of this part so that we can put in some commas and see if we can figure out how much this is. How much money is that?
440 billion.
That's right. $440 billion. Here are the hundreds, thousands, millions, billions. Is there a slight difference in the way the money grows?
Yes.
With simple interest, it was $5,000, wasn't it?
Yes.
With compound interest, it's $440 billion. Is there a difference between $5,000 and $440 billion? Yeah. You couldn't live the rest of your life very easily on $5,000. Could you live on $440 billion? You could probably eke through. Okay? What's the difference? The way the interest is compounded. In the first case, they just pay you the same interest one time a year. In the second case, they're paying you interest on the interest, and it compounds. It builds on itself. Okay, So what does this have to do with retirement? Things of that nature. You get a job. Looks like most of you are taking home around $3,000 a month, something like that. Okay. Which means you'd be putting how much into retirement each month? About $300. Now remember, your company, in most cases, will also match up to a given percentage of your income. So if you're making $40,000 a year, 6% would be about $2,400. So if you put in $2,400, guess how much they'll put in? $2,400. Okay, so you start out and you're remembering this, and you go down to HR and you figure things out, and you put in some money, the company puts in some money, and let's say it works out to be $4,500 a year total. Okay? Say your paycheck goes down by maybe $200 a month to get in $4,500 a year because you're not paying taxes on it. Okay, it's not going to be as dramatic of a change from money that would have been taxed. Stock market usually pays about 10% in the long run. Sometimes it's up, sometimes it's down. Last 100 years, average return's been about 10%. Now, I don't want to paint this picture to be overly optimistic. I'd rather under forecast the amount of money that you're going to have and say, hey, you're going to have $2 million. When you come back in retirement, you got $3 million. Are you going to be mad at me? Chuck, you screwed up. I've got an extra $1 million. That's a whole lot different than saying you're going to have $2 million and you come back and there's $700,000. Are you going to be happy about that? Dude, what did you do with the rest of the money here? We got to have a talk. Okay? So if we underestimate, that's better than overestimating. You can learn to live with more. It's better of the two scenarios. Let's say the interest rate is 9%. Okay? And, let's say you're going to let it ride for 35 years. If you start working at about 24, 25, 35 years, it's going to take you up around 60. Okay, if we put that money in as simple interest, I'm going to work that off to the side. Simple interest means that at the end of 35 years, you're going to have your $4,500 plus you're going to have 35 payments of 9% of that amount of money. Well, I'm going to take 4,500 times 0.09 equals. So each year, they're going to pay you $405 in interest. Does that make sense? So each of those years, you're going to get $405, and you're going to get paid that much 35 times, aren't you? So that's going to give you about $14,000. Plus, you've still got the $4,500. So this is going to work out to be, in 35 years, this will be about $18,675, which in itself is not horribly exciting. But remember, this is just 1 year, isn't it? Are you going to keep putting money in every year? Well, sure. So this is going to happen each of the 35 years. And every year, will you get the same amount of interest? Well, the next year's money is only going to be there for 34 years, isn't it? Yeah, they're only going to send me 34 checks. And the year after that, 33 and 32. And one of them is only going to give 1 year's worth of interest. So do you see the interest is going to be dropping for each additional year? There's more money going in. Okay, I'll give you that. But it does not build up to be quite as much in the final analysis. Okay, simple interest, you get back about $18,675. Let's do this with continuous compounding and see how much of a difference that makes. It's not going to be there for 535 years, so don't expect billions of dollars. Okay? But the amount of money that you would have in 35 years is equal to $4,500 e raised to the 0.09 times 35. So we have this 4,500 times, the first thing you do is to compute what e to that value is. Are you okay with doing that? Okay, so I'm going to do e raised to the 0.09 times 35, close the parentheses. And this number works out to be 23.33 something or other. I'm not going to copy down all the digits. But it gives you an idea of about what your calculator should be giving you back. You take that times the $4,500 that you and the company put in. Whoa, this is interesting. That $4,500 is going to have grown to how much? Really? Is that right? Did you mess up, Chuck? No. That's what it's going to grow to. And this is kind of a conservative estimate. It might even be more than that. $4,500 grows to $105,000. Now remember, that's just 1 year's investment, isn't it? The next year, you play the same game. Except this year, it's only going to be in for 34 years. Why 34 years? You're 1 year closer to retiring, aren't you? Oh yeah, you're a year older. Whoops, not 35 this time. It's going to be 34 this time. This amount's going to be smaller because it's not in investment as long. So we're going to do this 4,500 times e to the 0.09 times the 34. Okay, well, it's worth noticing. It's about $96,000. Now, if the first 2 years you're working there, you put money in and you never put another penny in, when you retire, how much will be in your retirement account? About $200,000. Does that make sense? If you never put in another penny, the first 2 years' investments will have grown to about $200,000. However, if you keep this up for the entire time, okay? If you keep this up for the entire time, we'll do some calculus here real quick, because there's a quick way to do this. Times e negative 0.09 x close the parentheses, comma x, comma 0, comma 5 equals equals okay. It looks like in the end, if you keep this up, you're going to have about $2.5 million. Now, do you just pull all that money out of the bank on that day and have a massive party? No, it's in a retirement account. If you pull it all out, the government's going to take 90% of it in taxes. Oh. So what you do is you take a disbursement each year. And you take this money and you move it someplace safer, where it's not making as much, but you're not as likely to lose your money. Let's say it's only making 6%. What's the interest on that? Well, it's $150,000. That means that every year for the rest of your life, you leave the $2.5 million in there, and every year you're going to get a check for how much? $150,000 before taxes. Now the catch is, I know it. There was a catch. Two things. One, if you don't spend $150,000 and you put it back into the account, what's going to happen next year? You get more than $150,000 back, don't you? At this point, do you still own your house? Probably not. Hopefully it's paid for. You still owe on the cars? Hopefully not. Kids are gone, they're out of college, they're on their own. What have you got to spend money on now? Vacations. $150,000 a year will get you a nice vacation. Oh yeah, there's one other little thing here. This is what a loser looks like. This person's a sorry loser. Doesn't look like a loser to me, Chuck. Got $2.5 million there. This is assuming that over the entire course of their career, this person has never gotten a single raise because they're still putting the same amount of money in every year for all 35 years. They've never gotten a raise. I would say working at the same company, never getting a raise in 35 years is a loser. This is definitely a worst case scenario, isn't it? Because do you plan on working at the same place for 35 years if they never, ever, ever give you even one raise, ever?
No.
So this is kind of an underestimate, you're saying, Chuck? Yes, this is kind of an underestimate. Aha. So this stuff can really make a difference in my life? Yeah. It's not hard to wind up with $3 or $4 million sitting there in an account with your name on it by the time you retire. All you got to do is start early and be consistent. I wish somebody would have told me this when I was 18. Dead serious. Yeah, but Chuck, that isn't the way it really works, is it? Okay, I'll give you an example. My wife's grandmother passed away about, I'm not sure, I guess it's been maybe, probably close to 15 years ago now. Okay. When she passed away, Becky's grandfather had already passed away, so what savings they had was passed down to their children. Well, Becky's dad and mom said, well, we really don't need it. Don't give it to us. Just pass it on to our kids, 3 girls. So each of the girls got about $20,000-ish. And Becky said, what do you think we should do with this? I said, you know what I'm going to say. And she said, really? And I said, what would Grandma want? Okay? And Grandma was a character. She was raised during the Depression. So do you think she threw money around? Okay, when we would go over to eat, you know, the paper napkins that you buy, she would take the paper napkin, open it up, tear it into fourths, and each person would get a fourth of a napkin. Because you really don't need the whole thing, and why waste it? Grandma would have been all about saving this money. Okay, it's been in there about 15 years now. We started out with how much? 20? I just checked it last week. It's all, right around 90 in 15 years. I told Becky. She said, really? I said, what do you think Grandma would say? She's probably got a big grin on her face. She's dancing around. Yeah, look at that. That's the way to do that stuff. You can do real well with this without ever making $100 zillion. You just have to be purposeful and consistent. It's got to be one of the things at the top of your to-do list every month. Don't come back in 35 years saying, Chuck, you didn't tell me, and now I've got to eat dog food. Okay? Do this. Okay? It really works. This isn't just a math problem. This is the way it really works. I promise you, it really works. And then some people will say, well, what if the country goes bankrupt and I lose all my money? Dude, if the country goes bankrupt, you're going to have bigger problems than your retirement account's gone. Okay? Well, and this is one of my family members. We don't bother saving any money. Who knows if we're even going to live that long? My comment is you might be right, but if you do, you're going to be in sad shape. Okay? Let's take a look at some other ways to compound interest. This is continuous compounding. The earlier one was simple compounding. There is a third way to compound interest, and that is on some period of time other than just continuous. Okay? There's a third formula for compounding. And it runs off of a different formula. The formula is P of T, so the amount of money in the end is equal to the initial amount. This one gets a little more complicated, but it's okay, you can work through it. 1 plus R over N to the N T. Let's do this one in a different direction. Let's call this student loans. Okay? When you take out a student loan, let's say freshman year, they don't charge you any interest on that till you graduate and get a job, right? El wrongo.
No, 6 months.
Well, when you have to start paying back is 6 months, you're right. What most folks focus on is, when do I have to start paying it back? And it's like 6 months after you graduate. However, listen to this question. When do they start adding the interest to what you owe? Right after you sign the paper, they start piling on the interest. Okay. I didn't realize it worked that way. I thought that that was 6 months after I graduated too. Hey, here's one for you. You graduate and you can't make your payments on everything and you go bankrupt and your student loans go away, right? If you go bankrupt, your student loans go away.
No, you can't have for the rest of your life.
That's right. Those are guaranteed loans. As long as you are alive, you will pay them. And they will come and take away whatever they have to take away to get their money back. My house? Yep, say goodbye to your house. Your car? Yep, say goodbye to your car. Got money in the bank? That's first to go. Okay? So if you're signing on for these student loans, realize what you're signing on for. Let's say Chuck didn't know what he was doing. I'll hang it on myself, not on you. Took out a loan for $10,000 and figured, I can probably make this last all the way through the program. I can graduate with just this $10,000. I'll put it in the bank and I'll get some interest on it and blah, blah, blah. You've probably heard somebody say this stuff. And Chuck uses some of it for La Rosa's and some of it for McDonald's, and you know how that goes. Okay? Interest rate. Yeah, let's say it's 8%. Chuck takes 5 years to get through school. Oh, that means the money's just going to be sitting there for 5 years, isn't it? And it's compounded monthly. If it's compounded monthly, how many times a year are they going to put interest on? Every month. How many months are there in a year? 12. What if it's quarterly? How many times is the interest going to be put on? 4. If it's semi-annually, annual means year, semi means 2 or half, so it would be twice a year for semi-annual. Those are some of the normal ones. Semi-annual, N would equal 2. Quarterly, N would equal 4. Monthly, N would equal 12. So let's say they're going to compound the interest each month. So that's 12 times a year. Now, this isn't the total amount that I owe them in the end, but when I graduate, is the amount of money still $10,000 that I owe them? The question is, how much do I owe them now? Well, we want to know, how much do I owe them at the end of 5 years of school? The P sub 0 is going to be the 10,000. Going to do 1 plus the interest rate. Be careful, it goes back to a decimal. Over 12, because it's 12 months in a year. Going to take the 12 months times the 5 years. Well, gosh, Chuck, I don't even know how to put that into the calculator. Remember PEMDAS? Please excuse my dear Aunt Sally. You start inside the parentheses, don't you? See that fraction there? Start with that. Okay, so I'm going to do the 0.08 divided by 12 equals. Then I'm going to add the 1 equals. So the stuff inside, jumped on me there. The stuff inside goes to 1.006, I'm rounding off, 7. The next step is to take that 1.0067 and apply the exponent to it, isn't it? Because please excuse the easy exponent. Oh yeah, exponents come next. So what I want to do in the calculator is I have this number, 1.0067 raised to parentheses 12 times 5, close the parentheses. And that gets to be about 1.489. Okay? Now you take that times 10,000. Equals. Geez, how much do I owe them? By the time I graduate from college, that loan of $10,000 has grown to how much interest is showing up on that loan now? It's almost $5,000 in interest, isn't it? How much should I borrow? 10, and I've got to pay back the 10,000 plus another 5,000? No, it's going to be longer than that because you're not going to write him that check in one day, are you? It's going to take another 10 years. 15 years. Hey, you know that new car you want? There it is. Your new car just went down the tubes. It's your student loan. I hope you enjoy riding it around. Okay? Why do I point that out? There are ways to avoid them. Avoid them. It's called work.